Welcome to the 8.8 notes. Today we're going to learn the quadratic formula. So we just learned about taking square roots, which only works in certain cases. The quadratic formula will work for any quadratic polynomial. It works every time, but it doesn't mean it's the easiest way to do this process because it's going to be a difficult process. So we really kind of only use it as a last resort when we can't take square roots and we can't factor, because that's usually easier. So factoring and taking square roots are going to be your first choices, but this will also work. So if you only know one thing, quadratic formula is it. But it's going to take you a while to do this if you use this every time. So here is the quadratic formula. Okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is what we're solving for, right? So x is part of our equation here. A, b, and c are our coefficients of the x squared term, the x term, and then the constant. So what we need this equation, we need it equal to 0. And then we look in front of x squared. If there's nothing there, we say it's 1. In front of the x, if we just see an x, it's 1. If there's nothing there at all, it's 0. And then the c term, okay? So we plug in those a, b's, and c's, not the x's, right? We're solving for x, so we should only have numbers that we're dealing with. So we want to make sure our equation is in standard form, right? So that means our a, b, c are in order and equal to 0. We have to identify a, b, and c from those coefficients. So again, if you see just x squared or x, then the coefficient is 1. We substitute those a, b, and c's into the quadratic formula, which was above here, and then simplify. So here's kind of your steps if you just want to help, like just so you have something to go through. We want to simplify our negative b. So we're going to think opposite of b, right? Because b could be negative. Then we're going to make it positive. We're going to do our exponents and multiplication because that's all part of, this is kind of following PEMDAS, right? There's our EM, right? There's our A and S. And we're going to do all of this stuff and then simplify the radical. If we have a common factor, then we can divide it out, okay? And sometimes we're going to get, if our radical disappears completely, right, that means we can get two distinct solutions. So that's where we're going to keep going until we get actually two numbers. I'll show you some examples where we do that. Okay, we have one worked out example. So here's our example, right? Here's our equation, x squared plus 5x plus 4. So we have to identify our a, b, and c. Well, a is the coefficient of x squared. So I'm not going to use x. I'm going to use a equals 1. Then we're going to do b. B is 5, and then c is 4. So these are the three numbers that we're going to plug into our quadratic formula, like so. So here's our substitution step. So we put negative b plus or minus b squared minus 4ac all over 2a. We're going to simplify by doing the opposite of b, so it's just negative 5. Doing our exponents and multiplications inside that radical. So 5 squared becomes 25. 4 times 1 times 4 is 16. And then 2a becomes 2. So 2 times 1 is 2. Then we're going to add or subtract inside the radical. So now our 25 minus 16 has become 9. Square root of 9 is 3. You can see that plus or minus is already built in there. And then, so see now how our radicals disappeared? So we're going to split into two equations, okay? So negative 5 plus 3, so here's our plus equation, and here's our minus equation. So we're just splitting that plus or minus. So this one's our plus or minus, and we're splitting into plus and minus. So negative 5 plus 3 is negative 2, and negative 2 divided by 2 is negative 1. On the minus equation, negative 5 minus 3 is negative 8, and then negative 8 divided by 2 is negative 4. So you can see we got two solutions, different numbers. Yeah, that was a lot of work, and that's why we only use this when our other methods don't work. Okay, so now let's do a couple of examples. So I just put a very brief quick steps up here just to kind of remind you what we need to do. So our equation needs to be in standard form, right? We have to identify our A, B, and C, substitute them in, and simplify. Simplify has a lot of steps, but it's all just following your order of operations, okay? So let's do an example. So first thing we need to do is identify A, B, and C. So remember, A, when we just see x squared, is really 1. B is 5, and C is 3. And you can see how these are all positive. The signs do matter, but we only have positive numbers here. If they were negative, we would write a negative number. So now I'm going to substitute those in for A, B, and C. So we have x equals, big fraction bar, negative 5, that's my B value, plus or minus 5 squared minus 4 times A times C. I'm just looking at my A, B, and C numbers as I fill this in. So I'm looking at my quadratic formula to see what numbers go where, and then I'm looking over here to see what numbers I'm putting there. So on the bottom, it's 2 times A, so 2 times 1. Okay, I'm going to switch colors here for a different step. So now we're simplifying, right? So that was really the first 3 steps, right? It's in standard form. We identified our A, B, and C. That's steps 1 and 2. And then I just substituted it in for our quadratic formula. That was steps 1, 2, and 3. Step 4 is going to be the rest of this process, okay? So we're going to think about our order of operations. So we're going to do negative B. So negative 5 is negative 5, plus or minus. And now we're going to do our exponents and multiplication. So 5 squared is 25. And then 4 times 1 times 3 is 12. So we're going to do 25 minus 12, all over 2 times 1, which is 2. All right, already it looks a lot simpler, right? So we can go through our subtraction here in our radical. Make sure you do that first before we evaluate that radical. So 25 minus 12 is 13. So this is going to be radical 13 all over 2. Well, now what we have here, right, I can't simplify. So if I try to simplify radical 13, right, I could do 13 divided by, what are my smaller perfect squares? 9 or 4. And that's really it, right? And both of those don't work because 13 is actually a prime number. So this is our answer, and we don't have to write it any special way. We can just kind of circle what we have here. Negative 5, oops, I went too far. Negative 5 plus or minus radical 13 all over 2. So just make sure that fraction bar goes all the way across. If you're typing this into a program, you might need to make that fraction bar first and then put your stuff on top and the 2 on the bottom. So that's an example where we don't have any simplifying to do at the end. That's kind of like our best scenario for quadratic formula. But let's see an example where we do have to do a little simplifying at the end. So we're going to do the same thing here, right? We're going to start by putting this in standard form, which it is. And then we're going to identify our A, B, and C, okay? So our A is 2. Now let's be careful with our B here, right? So our coefficient of X is really negative 1, right? It's negative because there's a minus, and there's nothing in front of that X. So I know if it's just an X, we know it's 1X. And our C is negative 21. Okay, so again, those signs do matter. We have to make sure we do those, okay? So now we're going to plug this into our quadratic formula. So I'm going to write x equals big fraction bar. So negative b, so I'm going to put negative parentheses negative 1 plus or minus square root of, and again, parentheses negative 1 squared, right? That's my b value. Minus 4ac, so 4 times 2 times negative 21, so I have to make my fraction bar bigger, over 2 times a, so a is 2, and there we go. There's all of our substitution. Okay, we've done the hard part. Now we have to simplify, so we're going to go one step at a time. So that first part was the opposite of b, so if I see negative, negative 1, that's really just positive 1. Plus or minus, And now we're going to do our exponents and multiplication. So -1 squared means -1 times -1, which is +1. Okay, and here's where we have to be careful again, right? 4 times 2 times -21. So let's see. 4 times 21 is 84, times 2 is 168. So this is going to be -168. It's going to be minus -168. Okay, which is then going to turn to a plus, right? So I know that I can think of that minus a minus, that's going to turn into a plus eventually in our next step, okay? All over 2 times 2, which is 4. So let's do some more simplifying here, right? So now I know that minus a minus becomes a plus. Just like our b value had a minus to a minus, that kind of became a plus. We can think of it that way. Whoops, what did I do? Hang on. So that was 4, and I don't know why it zoomed out here. All right, so this becomes 1 plus 168 inside the radical, which is going to become 169 inside the radical. Now, if I check my list of perfect squares, you might find that that is actually on that list, okay? The square root, we'll put this over here in a different color. The square root of 169 is equal to 13. So I can cross this out and I can put a 13 here. So let's do that in the next step. X equals 1 plus or minus 13 all over 4. Okay, so now here comes the tricky part, right? I have to split up that plus or minus. So I'm going to put a plus equation over here, which is going to be x equals 1 plus 13 over 4. And then I'm going to do my minus equation, which is 1 minus 13 over 4, x equals. So 1 plus 13 is 14. And 14 over 4 doesn't simplify all the way, but I can cut them both in half, so 7 over 2. Okay? And then 1 minus 13 is -12, and -12 divided by 4 is -3. All right, so those are going to be my two solutions. We're going to get x equals 7 over 2 and x equals, x equals -3. Those are my two solutions. We had to split this into two equations because our radical was fully simplified. Thanks for joining me.